Can't believe it. Get it right. All right. So let's see where we are. So in section 2.1, 65 and 70.
Yes.
So every X, you guys going. All right. So they tell you the lower limit. They give you an equation for the lower limit where A represents what? What do you think A represents?
Heart.
A. So they give you this equation. For the lower range, they give you H equals 7/10 over 220 minus A. And if you look at the very beginning of this section of problems, they actually tell you directly. But even if they didn't put that there, what do you think that would represent, that A? Look at the question. Think about, it's the letter A. H. It's crazy, right? Do you guys, so the 65A says, what is the lower limit of the heart rate range in beats per minute for a 20-year-old with this exercise goal? So that's the equation they give us, is the heart rate. So this has got to be H, because if I'm older, I'm going to put a different number here so I get a different range. I like it. So you just got to stick a 20 there for part A. Part A asks about the lower one. They give you two equations, one for the lower part of the range and the other one's for the upper part. So that part B is just the same thing. Just plug a 20 in.
Once you subtract the 20 from the 220, then you multiply.
Yeah, so height, heart rate equals 7/10 220 minus 20, because we're talking about a 20-year-old. So do the inside, of course, PEMDAS, parentheses first, and then you just do 10 in the, you just reduce it, right? And do 7/10 times 200. So you can just reduce that, go to town. I like it. If you go to the gym, you see those charts with the green, yellow, and red range. If you're in the red, you probably should slow down. And of course, it kind of moves as people get older. The heart rate allowance changes, and that's what this equation is for. I like it. This was page 110, section 2.1, number 65. So what was the, you had it done? 70, okay. Let me see, some flashes. Alright, while this guy is waking up, did you have a question?
I just had a problem. 67.
In 2.1?
Yeah.
Oh, okay. Alright. That's another visual, so I'll wait. The weird thing about number 67, you notice how, what does X represent in number 67 in section 2.1? What does X represent? Group, age group. So you see in the graph how they say group 1, group 2, group 3? So that's what X would be, 1, 2, 3.
Yeah, I plugged it in, but it wasn't the same. I didn't get the same answer. Back.
Oh, alright. You never know, they can make mistakes. Cool, there we go. People at home can see. There we go. So that's the graph they give you. There's the formula they give you, and X is the age group, and they tell you the group numbers up here. So 67 says, what percentage of Americans age 60 and older? What's happening? Where are we at? This is number 67, right? Don't want to get too far along. Okay,
You said 67?
back here. I'm sorry.
Oh, okay.
You'll hang on for a minute.
Oh, no, he was just confused.
That's right. He'll be all right. So which group am I talking about if it's asking about 60 or older? Group 6. Cool. So you're going to plug a 6 into the equation. Don't forget that negative sign. That's easy to forget. So
I was putting a 10 in there.
you're putting a 10? Oh, because you're looking at the number of people that are in there. That's not what the formula's based off the group. Yeah. I see. So you put 6 in there because it's group 6. I like it. And what's that look like it should come out to be close to? What percent? Well, I mean, they tell you. 10%, right? 16%, so forth. So it should come out close to the number 10. So what this equation does anybody know, we haven't talked about graphing yet, but some of you guys should know what this would look like if I graphed it. Do you know what an x squared equation looks like when you graph it?
Parabola?
Yes, parabola. And it's negative, so it would actually be a down parabola. You guys semi with me still? See the negative in front? So if it's positive, it's up parabola, sort of like related to slope. It's positive. If it's negative, then it's down parabola. And do you see how this looks like part of a down parabola? Wow. So this equation models how this graph moves. So when I put in 5, it's going to come out with a higher number. 4 is going to come out with a higher number. 6 is going to come out with a lower number. That equation will, because it models how those bars move. Like it's maybe. This is just a plug and chug problem, though. That's all it is. They give you the equation, and then they say 60 and older. Well, that's group 6. I'm going to plug a 6 in for x, and I know it should come out close to 10 because that's where it's supposed to be. I like it. Okay, cool. Now looking at number 70. You're so welcome. You gotta have faith. I'll get there eventually. This one says, use the line graph to estimate percentage of students who anticipate a starting salary of $40,000 in this economy. So let me just. So, what percentage of students anticipate a starting salary of $40,000? Here's $40,000, right? So, what percentage estimate that? Like 14, maybe. It's right in between 12 and 16. So, I'd say 14. Is that cool? Just hit 13. I'd be cool with that. As long as you don't say 28 or something crazy. Where the hell that? Maybe. So that's part A. And part B says use the formula. Whoop. So just like before, there's a formula that models this. Does this look like a perfect parabola? Hell no. But this gets close to it. There's a whole range of math study that says, I observed these temperatures. Now I want to predict what's going to happen here. Well, I can find a math equation that models that and then use it to predict what's going to happen. You do a lot of that actually in statistics too. It's called correlation studies. Like I showed you with the grades, and then I overlaid an equation, that black line. Remember that? I showed you the blue measles picture. Didn't I show you that? I love it. If you didn't see that, like blue measles. What the hell are you talking about? All right. Hopefully nobody shook their head. But you remember that? I showed you the grades, the homework, the grades and the stuff, and it had the black line going down the middle. So that black line kind of estimated where the points were, and there was an equation that went with that. So I could predict what would happen if somebody did less homework, did more homework. Okay, so for this one, what are you going to put in for S, though? What will you put in for S? Remember, it was all about $40,000 salary. Estimate the percentage of students. So what are you going to put in for S? 40, yes. Now look, I think most of you guys know, you just don't want to say. Feel free to say something. I'm not going to make Funny you get it wrong. Aha. What is going on? What's happening? Stay with me now. So if you look at the graph, 40 seems to go to 14. Using the equation, just like in the last problem, can you show what the equation would predict? Well, what are you going to put in for S? 40. Are you going to put 40,000 in for S? Hell no, because S is in thousands of dollars. So you're going to put 40 in. If I wanted 50,000, I would put 50 in. Thankfully, the expectations go down. There are people that expect to make $70,000 a year coming right out of school. Well, they can expect as much as they want. All right. Yes, no, maybe so? Yes, no, maybe so. Okay, okay. Anything else from homework stuff?
51.7.
Oh boy. Something like that. Don't forget the negative.
So the point for 69 is you plug in 40 with an S.
Number 70.
Oh, number 70? Oh.
Yes.
Oh, my
And that's
God.
why it makes sense, because they're talking about $40,000, so S will be 40, because S is in thousands of dollars.
19.7.
There you go, 19.7. And what we predicted it was supposed to be, we said it should be around 14, so 19.7 is too high. So this parabola might do something like this. The parabola might kind of follow this, and it just gets too high of an estimate for right there. Okay, maybe. This is not a perfect parabola there. Okay, maybe. I love you guys. Let me see. So what's happening is, this parabola, if I graphed it, it might look something like that. So we overestimated, so it should go further that way. So it's not perfectly following that line, but it's the best approximation for a square that I can make. Okay, maybe. Just like here, this looks pretty parabolic actually. Right? So that's why this one came out pretty close. So it should come out pretty close for the answer we did over here. Like, nice parabola. Okay, cool. So does anybody surf? Anybody know somebody who surfs? Anybody go to the beach and interested in the tides? Anybody ever look at a tidal table? So if you look at the tides, they kind of do this kind of thing. If you record the tide every 1 hour, they can record how far in the water is. And then you can match it with an equation. This equation would actually be something called a sine wave. Right? But you can do observations of real life and then see what would match that well enough that I can make predictions for later. And of course, how the amplitude depends on what's happening in the world. Right? There's a hurricane. Well, we live in California, so it's never a hurricane off the coast. But if there were, or there's a big storm coming or whatever, then that's going to affect that. I've got to build that into my formulas, right, to predict what's going to happen. I like it. I like to go kayaking on the East Coast. I'd always check the tides out because there were certain areas I couldn't make it back to the dock if the tide was coming in because I couldn't make it under this bridge. I'd have to get out, carry my kayak. I was like, damn it, I should have checked the tables. Shit. Good job, Jeff. I could get under there, going out, and then coming back, I'm like, well, that ain't going to happen. Anyway, all right. So check the tables. And hopefully whoever made the predictions used the right equations. I'm going to write a letter. All right. Anything else from homework stuff? Yes?
Page 135, over 57.
Which one, sir?
57.
57. Okay, good. So I've been waiting for questions from this section. Let me build up to this. You said 57, right?
Yeah.
Okay, let me build up to it. Oh, shucks. So you should all thank her, because I wasn't going to say a damn thing about this until somebody actually asked me. which tells me people are actually doing the homework. So it's come up now, so thankfully for you, we're going to talk about it. How would you solve this for the letter A? What would you do?
Add B and then divide.
Cool, I like it. You do exactly what you would do. So tell me this, how would you solve this equation for the letter A? It's one like that one. You guys have got to stay with me.
Plus 5.
Yeah, you would add 5, right? Because there's my A. I need to get rid of stuff that's with it and then divide by the number that's with it, right? So I do the exact same thing. Even if I have more letters, who cares? It's just stuff that I don't want. I don't want that 5, so I'm going to add that 5 over. I don't want that stupid B, I'm going to add the B over.
Which number is this?
This is related to
Oh.
section 2.3, number 57. I'm kind of building my way up to that. Alright. So an add B. What's 7D plus B? 7D plus B. I love it because I don't know what the hell it is. They're not like terms, I can't combine them. So that's the one difference between this. If I add 5 here, of course, 8 and 5 is 13. Yay, because they're like terms. When I got a bunch of letters sitting around there, I can't, there's not going to be as many like terms. And of course, the last thing I do, divide by 2. I like it. So A equals 7D plus B over 2. Coolness. And this is the part where students are always like, what the hell are we doing this shit for? Playing around like, because when you have an equation written one way, you want to be able to rewrite that equation a different way because then maybe it's more useful. So you have to be comfortable moving letters around also. I like it. So let's see, what about this here? You put no numbers in here at all. I like it. Solve. Bless you. Solve for M. Oh shit. So what's the worst part? The fact that there's no letters is bad, but what makes it even worse beyond that? There's a fraction in the damn thing. The nice thing is an equation. I always want to kill every fraction I see. Write down fractions. But I'm not allowed to do it unless it's in an equation, unless there's like more than one side to it. Because what am I allowed to do now to kill that fraction? What's making that fraction? The fact that this is divided by CX. So how do I undo that? Multiply by CX. So if I multiply both sides by CX, I get, bam. Somehow somebody has this go through, but I'm like, it's dead. It's dead. There's no zombie CX going, no. Alright. Or maybe there is. You can draw me a little picture of it. So, dead. So I get A plus M equals CXY. Is that cool? So if there's a fraction in your equation, I don't care what it looks like, you can kill it. Multiply by its bottom, it's dead. And what's the last step here? Subtract A. Kick ass. Sure. Yes.
Would it be, like, can you leave a line in parentheses and then CX next to it, minus it, or am I writing it wrong?
I mean, technically you're right, but it's sort of like writing this, x5. Oh, that's 5x, right? I mean, yeah. So there's no need for those parentheses, and you normally kind of put it in alphabetical order, just to be done with it. Yeah. But you could write ycx, But you don't need those parentheses. I want them out of there.
I see X.
The only reason I put them in is because I'm multiplying that side by CX. But then I don't need them immediately, don't need them.
Because no matter what order they all go in, they're all counted by.
Yeah, it doesn't matter what order you multiply. I like it. Here, you guys try these. What you got, Jeff? I don't know. Oh yeah, let's do this. Ooh, it's gross. I like it. And then I'll finally do the question you actually asked. I just wanted us all to be on the same page. That's a Q, yeah. Sorry. My poor little Q's. Is that better?
Yeah.
Almost doesn't matter what it is as long as it's not a V. V is my most important variable in there. On the nose. Thank you. So this first one shouldn't be bad. I mean, how do you always solve any equation? You find where your variable is. You get rid of anything else that's with that term. So what am I going to do first here? Subtract b. The last thing I'm going to do is divide. So I subtract b. Y minus b is y minus b. Divide by x. So m equals y minus b over x. Yes, this is the equation of a... Sure, there's slope in it. It's the equation of a line. It's the equation of a straight line. You guys, hopefully most of you should know that. Y equal mx plus b. Oh shit, the slope, the y-intercept. Am I looking at it like that at all right now? No, it doesn't matter. This is sort of related to the force an electric charge feels when it goes into an electric and magnetic field. Do you have to know any of that shit? No. It's a bunch of variables that mean something. But all I'm doing right now is rearranging the equation. I don't have to understand the ideas behind the equation to do that. So what do I do first on this guy? Yes, there's a fraction somewhere in there. I want to immediately kill that so that everything else is free to move around. So I multiply by W. So I get FW equals die.
QV plus B.
QV plus B.
Subtract B.
Good. I'm trying to solve for V, so now I'm like here now, right? That's where my V is.
And then divide by
So I want to get rid of this. Minus B. FW minus B. I don't have a clue what the hell that is. I always have somebody that writes this as FWB. But what is FWB?
Multiply.
Multiplying. How the hell would subtraction become multiplication? I don't know. You got to show me that one. Teach me. But no, that's not true, so it's not. Don't teach me. So then over here, QV, and then you just divide by Q. So V equals F W minus B over Q. Oh my God. Real quick, before I do the problem that I was asked about, I don't know, I don't know, people expect like more out of this or something, or they expect,
Because it doesn't look right, like equals
how do you mean it doesn't look right?
it's not like simplify, you know.
Oh yeah,
We just like to make things more complicated.
what's the
We
matter?
overthink.
Oh,
Yeah.
okay. Maybe, no, but I think you're so used to getting at the end having x equals 7.
Yeah.
I think it's sort of like what you were saying. The here, I don't know shit, so it should look at least as bad as it did to start with. But bad meaning I don't know any of this stuff, so no matter what I do, I still don't know any of that stuff.
It's okay if it's messy.
But I've created an equation that might be better to use in other situations, right? So, two things. So this equation here, if I knew m, x, and b, this equation is good. Let's say I gave you 10 problems and I told you m, x, and b. I told you like the first problem was m is 7, x is 2, and b is -8. You can plug it in and figure out what y was. Are you guys with me? That's really basic algebra, just substitution. But what if I then said, well, now I'm going to tell you what y, x, and b are. I want you to solve for m. Here's 20 problems where you got to do it. So if I told you, for example, if I said y is 5, x is 3, and b is 1, could you solve for m? All right, do it real quick. Right? Just plug and chug, right? Is that cool? And then you would do what?
Subtract 1.
Subtract 1, so you get 4 equals 3m.
Divide by 6.
So you get m is 4/3. So real quick, we're not into lines yet, but just to remind you guys, this means that if the line goes through the point 3, 5, right, and has a y-intercept of 0, 1, the slope would have to be 4/3. That's what that means. That's what all those letters refer to. Do you have to know that right now? No. Now watch. What did we get when we solved for m? We got m equals y minus b over x, right? So if I plug in y, x, and b into this, it better freaking come out to the same damn thing, because I am claiming that that and that are the same. Just what's better about this? If I had 20 of these problems to do, and then the next one said y is -4, x is 6, and b is 20, and then the next one said y and x and b, do you want to have to do this 20 times, or do you want to do it once and be done with it? Because what happens when I plug it in here? What's y? 5. B? 1. X? 3. 4/3. Bam! Next. Bam! Next. Bam! Next. That is the reason that we want you to be able to manipulate variables in an equation so you can make a better equation for a different situation. That's the main reason you have to be able to do that. As a student, I know it feels like I'm asking you to, now move that barrel over there. Now move that barrel back. Now move that barrel over there. You're like, move that X over there. And move that X over there. But there's an actual purpose for the skill. Okay. So final. Let's look at the, what was the other thing you were going to say, Jeff? I think that was it. Those were the two things. Okay. So your question This should look familiar. Let's see if they do it like. And then once you solve for n. Solve for n, not for n. Solve for n. So what's kind of wrong with trying to solve for n right now? There are two ways to do this problem. Well, what's kind of wrong with what's happening with the n? I can't do something because it's...
Exponent?
There's no exponent here. What do I mean? If that d wasn't there, it would be easier to solve for n, would it not? Because then I can just add the 1 and get the hell. But that it's now the n is inside, stuck. So there are two ways to kind of do this. And we know the first step in solving equations normally is distribute. But you don't have to. But if we do, then everything's free to move around, right? So try that first. Try to solve it. You're trying to get n by itself, but my suggestion is to first distribute. So try that. If you can think of another way to do this, try it that way. And then I'll show you both ways.